in this example, we do have n equal size circles, and the radius of these circles are unknown. We want to find the biggest value of r that can have. In this example, we are about to allocate n equal sized circle inside the unity circle, and we want to find out the maximum radius of these equally sized circles. And the big circle has the radius equal to 1. Okay. The condition for this specific optimization problem is that no two circles have any overlap with each other, and they are all inside the big circle. So first inequality is telling us they are not having any overlap. The second one is making sure that they are all inside the big circle, and that big circle is the center of that big circle is located on the point 1 and 1. Okay, for simplicity. Let's have a look at the Python code. So first we import every required package, then we define an abstract model. N number of circles is a parameter. It is mutable, so it can be changed. I is a range set starting from 1 to n, which is the number of circles, and j is the alias of I. R, x, and y are variables. They are changing between a small number and 2. And also we need to define some rules for that. As we said, the first rule is making sure that no two circles have any overlap. The second one is making sure they are all inside the big circle, and the objective function is, let's say, r square or r. Okay, so we can maximize r or r square. So let's maximize r. Okay, and also instance will be model.create instance. So after this line, all the constraints will be created and supplied with the input data, and also the results is obtained here, opt.solve instance, and the created instance will be solved using the solver that we already specified. Okay, and finally the results are plotted here. So I run the code for you and show you the results. Okay, so here you can see that for 20 circles we can have these results. Okay, and the location of these small circles and as well as the radius of them is found.